Okay, so let's dive into something that feels like a total paradox in AI. We all know that large language models train on the internet, right? But think about it for a second. The internet is, well, it's a mess. It's filled with typos, bad facts, nonsense, you name it. So how in the world does an AI learn to be so coherent, so smart, from such a chaotic teacher? Seriously, think about this. If you gave a student a textbook that was just riddled with errors, you'd expect them to learn all those mistakes. But somehow, these LLMs churn out brilliant, creative text. On paper, this just shouldn't work. So what is going on here? What's the secret? Well, to crack this puzzle, we first need to imagine what learning would look like in a perfect world.
All right, so researchers actually have a cool way to think about this ideal scenario. It has a fancy name, language generation in the limit. But don't worry about that. All you need to know is it's basically a simple game.
So, picture a game with two players. On one side, you have the learner, which is our AI, and on the other, you have the adversary, who knows a secret language. The adversary's whole job is to teach the learner this secret. And the learner, well, it has to prove it's paying attention by coming up with something totally new.
Here's how the game works, step by step. First, the adversary picks a secret rule. Something simple like, all sentences must be about cats. Then it starts feeding the learner perfect examples. The cat sat on the mat. The cat chased the mouse. Now here's the catch. After every single example, the learner has to try and guess a new sentence that still follows the secret cat rule. The game is over, and the learner wins, only when it gets so good that it literally cannot make a mistake anymore.
And here's what's wild. Researchers figured out that in this perfect little game, with perfect data, the learner can almost always figure it out and win. The theory checks out. Learning is totally possible. But you know where this is going. We don't live in a perfect world, and the internet is definitely not a perfect teacher. The reality is that the data these LLMs train on is, to put it lightly, contaminated. The research we're digging into today breaks down this messiness into two main problems that make learning way harder.
So the first type of mess is what they call noise. Just imagine our perfect teacher from the game suddenly starts throwing total garbage into the lesson. You're trying to learn all about cats, and suddenly you get a sentence like, cats have wings and breathe fire. That's noise. It's just plain wrong information getting mixed in with the good stuff.
The second type of contamination is called omissions, and this one is a really big deal. It's not about what's there, it's about what's not there. It means the teacher isn't telling you the whole story. I mean, think about it. Not even the entire internet contains every possible true sentence that could ever exist. There are always going to be gaps, and that means the learner has to figure out the rules of the language without ever seeing all the possible examples.
So let's just put this side by side. On the left, you've got the clean, perfect, theoretical game. And on the right, you have the absolute chaos of the internet, a messy, unreliable teacher that sometimes lies and definitely doesn't tell you everything you need to know. So the real question becomes, just how much messiness can a learner actually put up with before the whole thing just breaks?
And this is the exact question that this research paper digs into. Where are the breaking points? At what point does all the noise and all the missing pieces of the internet make learning theoretically impossible? And the answer they found is, honestly, it's pretty stunning.
It turns out the answer completely depends on what you're trying to learn. If your goal is just standard generation, so just producing any single new correct sentence, the learning process is actually pretty tough. It can handle a lot of mess. It's like learning to play one more correct note on a piano. Even if you hear a few wrong ones, you can probably figure out the next right one. But if the goal is what they call dense generation, learning the richness, the variety, the entire song, the system becomes incredibly fragile. The theory says it should completely fail with any unending stream of bad data, no matter how small it is. And this leads us to an even deeper paradox, because when you look at today's LLMs, they aren't just correct. They're creative, they're expressive and varied. They are masters of dense generation, but they learn from the messy internet, the exact place where that kind of deep learning should be impossible. So what gives? What are we all missing here?
Okay, so there has to be a solution, right? The paper proposes one, and it builds a brilliant bridge between that fragile theory and our messy reality. Turns out it might not just be about what data you learn from, but how you learn from it.
So yeah, how do we explain this magic trick? How do these models pull off this supposedly impossible, fragile kind of learning in the real world? The answer might lie in a strategy that, every good teacher and every student already gets intuitively. It's a concept called curriculum learning. And the idea is really simple.
You wouldn't start learning math with advanced calculus, would you? No! You start with 1 + 1 = 2. You build a solid foundation with the easy stuff, and then you gradually move on to the more complex ideas. The order in which you get the information, it matters. A lot.
And boom, this is the breakthrough. The researchers actually proved that if the messy data isn't just a random jumble, if it has some kind of natural structure, where simpler ideas tend to show up before the more complex ones, kind of like a natural curriculum, then even that super fragile, dense generation becomes possible again. The curriculum basically saves the day.
So, let's bring this all home. What does this mean for building AI in the real world? Because this isn't just some abstract thought experiment. It really points to something fundamental about how these incredibly powerful systems actually manage to learn.
I mean, the authors of the paper say it perfectly. This isn't just some lucky break. They suggest that this curriculum effect, this accidental, natural ordering of information on the internet from simple to complex, might be one of the main reasons AI can learn so incredibly well from the web in the first place.
So if there's one thing to take away from all this, it's this. We usually think about AI training in terms of just the massive amount of data. But this research suggests that the structure and the order of that data could be just as important, maybe even more so. It's not just about drinking from the internet's fire hose, it's about the sequence you drink it in.
And that leaves us with a really fascinating question for the future. If this sort of natural, accidental curriculum that exists on the internet is already this powerful, what could we do if we actually designed these curriculums on purpose? Could building deliberate, carefully structured learning paths for AI be the key to the next generation of models? Ones that are not just more capable, but maybe more reliable and understandable too? Now that's a thought. Thanks for diving in with me.